I'm going to do a top again, if no one objects. So before I did that outline and then rotated it. This time I'm going to just extrude some rounds. And so then I can show another useful feature in here. Okay, so creating sketch, coming in here, diameter, Duke, and I'm setting that for being 1 inch. And I'm actually going to make that, stop that. I'm going to make that construction. Now, almost always when you hear me say stop that, I am then hitting escape a bunch of times to get out of whatever mode it's trying to do. Okay, creating sketch again. And I'm going to then go over to, now there's something else we can do, actually. Let's see if this is going to work. I'm going to go over to offset. And okay, so I can't offset from that. So maybe I'm going to go to hit P for project. And I can project that circle there from my stock representation. And now I'm going to go to offset. I can click on that and I can offset that a distance in, like maybe I want that to be, make sure I leave 10 thou per side. Seems a little shallow. I'm a little nervous on just 10 thou. I like 20 better, honestly. That is to say, I like 20 because I don't trust the stock to not wobble or be egg-shaped or whatnot. And 20 thou per side is going to give me usually enough to clean that up. Okay. So there it is. And I'm going to then go to solid and extrude. And we see that it's just going to extrude that little inside circle there. And I'm going to bump that up. What do we want? A 1/4 inch or an 1/8? This is going to be the flywheel of the top. We have a vote for an 1/8. Okay. There it is. Ta-da! Okay, and then I'm going to create sketch again, and then I'm going to grab the face of that one. And there it creates a sketch just directly on that face. And happily, it puts the center of the sketch, the XY0, in the center of that circle. If we were nervous about that, as to whether that had actually done it, we could go to line, construction, grab a point on the side there, drag directly across to the other side, and making sure that it snaps to a horizontal. There's that. Then we can grab one up above, do the same thing. And then we can check to see if that is dead center of both lines. So yes, that WCS is directly in the center of that circle, which is what we were hoping for. Hooray. Okay, turning off construction, going to circle diameter. I'm going to go back to that center bit, grabbing that, dragging that out, going to diameter, setting the sketch diameter to 8.5. That's going to give us something to grab onto for op 2. There it is. Okay. Making sure none of you are buzzing me over. Okay, nothing to do with you guys. Okay, so, sorry, my phone was buzzing at me. Oh, I see a chat. No worries, Mr. Kenneth. All is well. Okay. so here we have that 50 thou. I'm going to escape out of that in theory. Come on, you're not escaping out. So we're going to go to solids and we're going to extrude and we're going to grab that smaller circle in there. Dink. And I'm going to extrude that out by let's keep it an eighth. Sure, why not? Maybe, let's try 100 thou. Let's be a little more cautious in that. Click on the OK. And we're going to do the same thing again. And we see that it's lining up with the center pips from before. So I'm going to trust it this time. Oh, I went positive 100 thou because that's just the direction we'd be going on the previous. But do what makes sense for you. All right. I want this one to spin fast. So I'm going to set that diameter to being a 0.1 this time. And we're going to go to solid and extrude. So we've basically been doing the same thing several times there, over and over. Well, that's a bit too long, isn't it? So yeah, so we're going to go, let's try with a 0.5. Is that going to be long enough to grab onto? Maybe. Let's leave it, see what happens. All right. Grabbing that okay. And let's do it again on the underside. And this time I'm going to, once again, go with that 100 thou diameter, I do believe. Let's try that. And then we're going to extrude out a distance. Last time I did a 1/4 inch. I kind of like that. Let's do it again. Makes it easier to start. Okay. From here, we're going to start doing our modifications. That is chamfering and filleting. The last time I did all fillets, and I think I'm going to add some chamfers this time instead. So I'm going to do those first. I feel like it. Chamfer. I'm going to do one at the top here. Sure. Why not? And maybe we'll do one down here as well. We do all chamfers? All chamfers all the time. Yes, we are. Okay. All right. So this time I'm going to grab all of those and I'm going to have them all do the same thing. Let's see what a 20 thou chamfer looks like. Yeah, that'll do. I'll take it. Okay. And now we're going to do some fillets. And I'm going to grab this edge here and this edge here. And those are 100 thou. So I want to keep that at a 50. If I go over, if I go like a 55, it's going to error. Can't do it. I can only do up to the radius. All right. I like that. Okay. And then I'm going to do another set of here and here. And I'm just going to set those at a 20 thou also, I think, just to keep with the theme. Also to make it slightly more than our 15 thou tool nose radius so we get a better finish. I like having a little bit of a slope, and I think it spins better when it has a little more mass around the center. So I'm going to start another one at the base here. And let's see what a 200 thou. Nah. Half inch. I kind of like that. Let's see what a 3. Let's go back to that. 0.5. Yeah, I like that one. Okay. A bit of a different design from last time. A little more stark, a little more geometric. Okay. So in terms of the modeling, how did that feel? Are we okay? Do we think we can do that? Give it a go. Give it a go. Definitely. Okay. Now, here is the thing that is going to prove useful to us. See if I can make it do it right. So I'm in solid, going to create. And where did I put that? Is it modify? Yeah, okay. We're going to go with we have a couple options. We can go with a split body or a silhouette split. I'm going to go with silhouette split because, well, you'll see in a sec. Grabbing that one. Okay, now I'm going to grab one of those faces that's going right through the middle. So I'm going to pick this one because I feel like it. There's very little logic going on there. Just grabbing it. Okay, so for the view direction, I selected one of those panes. Now for target body, I'm going to select the whole thing there. And operation, split faces, split shelled body, split solid body. I'm going to go with split solid body. Bang. Now, look at that. It has split our solid into two pieces, which is kind of handy in that. Let's go bodies. You see now we have two bodies there. If I turn one of them off, I've got half of that part. So what I'm going to do then is go create sketch, and I'm going to grab that split face there. And now I'm going to project that entire face. So if I turn that body off, I have a perfect outline of my part. That, ladies and gentlemen, is handy, especially on the lathe. Okay, I'm excited. So what'd you guys think about that last little thing I showed you? Feeling good? That was in solids, modify, split body. No, sorry, it was silhouette split. And then I changed it over in this pane over here to split the solid instead of various faces. Okay, I'm going to finish that sketch. I'm sorry, sir, you're quiet and breaking up. And I have my volume at max. So you got to get closer to your speaker. Or your mic, that is.
Oh, there it is. It's back.
One more time.
Oh, my screen went black and I didn't see what you were working on, and now it just came back to the screen.
Oh, that would be Zoom having some issues. Sorry. So what point did I lose you?
Okay. I'm glad it's back though. Thank you.
Yeah. Okay. Speaking of which, I'm going to stop my recording. Okay, so that was the end of the design phase. And now I'm going to go back to begin recording here. Okay. Now we're going to go into the manufacture phase. So I go to design, come down to manufacture. Here we are. Cool and groovy. I might need the models turned on. So I'm going to turn those on just in case I need them. Okay, let's fire up our setup. Okay, so it's decided that it knows what we're doing and that we're going to be turning, and it is right. But just in case it starts out in milling, we're going to go to setup. They can change that to turning or mill turn. Okay, our stock here. So it defaulted to a 1-inch diameter and a 1-inch length. Let's give that 1.5 inches in length. Modeled the position offset to front. And we're going to offset that by 50 thou. So now the stock is bumped a little bit in front. And we're going to cut this step here in the first op because we need it for second. Okay. Now we're going to change a couple things. We need our X to be aligned with our drawing, which it is. That's good. We can see that this X is parallel to this drawing here, which is what we need. However, we want our origin to be model front. Doink, there it is. Very, very important. If you have your WCS on the front of your stock instead of the front of your model, your operator is going to think you're an amateur. And we don't want that. Okay. Now it's going to try to spin the model to try to figure out its outline. And we're going to let it. That's fine, because we can take control of that later. Now, if we go to machine, we might have some problems. Let's see what happens. I don't think it's going to do us any good. They are still working on their lathe machines for Haas. And we come in here and let's clear the filters. And those are all mills. There are no lathes. I have a lathe model that I don't remember how I got. I thought I downloaded it from their website, but I can't find that anymore. I might have downloaded it from Andy. I'm just not sure. I don't remember. So, but it turns out with some experimentation, I've seen that it doesn't need a machine to post the G code. So we're going to cancel that. Post process. All right, I'm going to pick a number. I'm going to go with this time with month, year, and this is the actually the second program I've done today. And this is 215 lathe 2 op 1. All right, now I'm going to pause things for a moment and have a chat with my multi-axis students. So give me a moment. Okay, I have returned. So from here, let's talk about tool pathing. First, we're going to face, and let's go select that tool. And now you notice it's calculating the spun profile. We don't have to use the spun profile. It makes it convenient. But because we split the whole thing in half and created that outline, we have more options. We're going to look at those. Because sometimes the spun profile goes crazy, does just weird things. Okay, so coming over here to turning tools, turning general. Now I want the right hand with a 30 thou-ish tool nose radius. If you can't see that part, come up, find that little line there. You miss it. There it is. And you can adjust how much you can see. Usually you start out right there. So open that up. Makes life easier. Okay, we want the right hand. Don't overthink it. Right hand. Select. Okay. Speeds and feeds, I'm not going to deal with right now. We're going to talk about those later using the machinist handbook. But I don't want to overwhelm you all right now. Okay. We do want constant surface speed. Yes, please. Very important. We also want feed per rev because that's what most operators are used to dealing with. Geometry. Okay, it defaulted to model front. That's fine. And we want to offset that to give it a little bit for our finish tool. So let's give it somewhere between 10 and 20 thou. I'm going to give it 10. I don't like this lead inline here. We're going to end up getting rid of that or changing the direction. Okay. So I go to passes and everything's looking pretty good. I like this. I don't need to change anything. Because we already changed adding the 10 thou there, I think, didn't we? Yeah, we offset that by the 10 thou. If you didn't want to do that here, you could do it in stock to lead as well. You know, make your own choices. Okay. Now, in here, as I mentioned, I don't like this 45-degree approach. So I'm going to change, same as lead in, I'm going to turn that off. I'm going to change the lead in angle to being 90 degrees. And I don't tend to like it to leave on an angle either. I tend to prefer it to come out in a 0. That's up to you, but your operator will prefer that 90 degree. It's less of a surprise. Oh, I forgot to check my radii. Let's look at that. Oh, those are way too big. I don't like those. Too big, too big. Now, one nice thing here is if I grab this olive color here, the outer retract, it tends to step in 100 thous. And 100 thou is usually what I like to use. So if I go 100 thou, 100 thou, then it does the same thing as what I normally do, but without me typing it. You know, do what you like. Okay. Now I've got a little bit shorter here, and that's just fine. Okay, there it's in the facing. Oh, I didn't check this though. I almost forgot. It's probably going to do okay, but I like to put in on the inner radius, distance to cut below is the tool nose radius which was a 0.315 something. I'm just gonna go a 0.32. I said 2. There we go. That is wrong. 0.32. There's a little bit of a difference. Squirrels. Squirrels running around in my brain. Okay, there we go. Much better. Okay, so now it's diving down about the tool nose radius below the center line of rotation. Groovy. Okay, now roughing. We got a lot to pull off there. So I'm grabbing there, and it grabbed the same tool. Again, I'm not dealing with speeds and feeds for now. We'll save that for maybe Monday. Geometry. Okay. Now, what it did here is when it was calculating that spun profile, it looked at the solid and decided, okay, based on that, here's what I think your profile is. And sometimes it's going to be right, and sometimes it isn't. If it cuts into your part, when you look at the simulation, then instead what we can do is we can go to model. I'm actually going to turn off one of those bodies there. I can go to chain, open chain, and I can start selecting all those little lines that we had created earlier. Remember that? That's facing the wrong way. Let me make sure it's, nope, I got a problem. I think I have a problem. We'll see. I'm gonna ignore it for now. I'm gonna see what happens. Okay. And let's see here. So in front, I'm not going to deal with the offsets here. We're going to try to deal with it someplace else. I usually prefer it elsewhere. Okay, but I am going to change the model back a little bit. And I think this is not going to work out for us. We're going to come back and find out why in a moment. But I'm going to offset the model back by the negative 0.155, which we had calculated before is going to give us a 30 thou facing plus room for the part off. Okay, there we are there. And let's bring that clearance down in to that 200 thou passes. Maximum depth of cut, we're going to take 100 thou radially. We're going to get in there and get a bite. Stock to leave. 4 thou is not enough. We want 10 thou radially and 10 thou in Z. And I'm going to extend that to the stock. We don't want it to groove down in here, as you recall. So I'm going to come up to grooving and say, don't allow grooving. Before we mess with this down here in the linking, let's see what it's going to do first. Bump, 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 bump. Ooh, that's nice. Now, it didn't go out as far back. It's supposed to be coming all the way back here, right? Remember that? We told it to. That's because this nose is curving down under, and so it doesn't know what to do. It got kind of lost and confused, just like me. So let's try something. See if this is going to work. going to go back to geometry. I'm going to reselect, and I'm going to grab that chain, open chain. I'm going to see what happens if I just grab that. Make sure it's going. I don't like that it's facing the wrong way, but it's on the correct side. Let's leave it alone and see if it does anything goofy or not. And I'm not going to select the end that curves under. Let's see if it behaves itself or not. Everything else is the same. Well, once again, it ignored us there. This one did pretty good in that, remember how before we did just kind of that nubbin so that it wouldn't bend the spindle. So now it's just coming in immediately. Now it's inside the face, and I don't like that. We'll have to make some adjustments there. It's going to get a little crashy otherwise. Don't want that. Is this what you must do? No, it's just a thought, a way. So let's make some adjustments, make this work better. And you notice I'm not just getting it right. I'm not just stepping up and doing it perfect. All right, I'll move that front out a bit. There we go. A little further out than we need. And I'm going to go to, on the back, tangential extension by a 0.155. Let's see if that does what we want. There we go. There we go. So the tangential extension came down along here and then swung out further. And because we didn't allow it to groove, it went straight back. And we're still out here in crashy land. I don't like that. Let's see what's going on there. Not to my preference. Nope, didn't do a thing. Okay. What about... Why is it ignoring me? I truly don't know. I'm telling it to start out here, and yet it's not doing it. So let's offset that. I'm gonna force a 200 thou. And let's give it a tangential also. There we go. There's that 200 thou tangential right there. So I can shrink that up. But you got the idea. Let's run it, see what it's going to look like. Face, zoom, 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 zoom. Yeah. That's going to throw some heavy chips. Definitely. Okay. And we're looking at not even half a second. Yeah, buddy. That's fast. Now, it's not going to be quite that fast in that this doesn't calculate the rapids very well, but you get the idea. We're looking at some real nice profit. Okay, next we're going to face again, but this time it is going to be turning tools, turning general. It's going to be with a finish tool. However, The finished tool, for some reason, is in the library defaults to 0.2 millimeters. I don't know why. That's okay. We can fix it. We'll go with select. Then we're going to go into select again. And then we're going to modify it, right click, edit tool. And we're going to go to the insert. We're going to change the unit to inches. And the corner radius, we're going to change that to a 64th. 1/64. And that's going to be a essentially a 0.015, so forth. So about a 15th thou tool nose radius. Now, let's go back here. Okay, that's looking good. So, right, and I'm going to put in a note saying that is coded for a 35-degree insert with a 0.015 to nose radius. Copy. Back in there. And it's got this funny thing going on here that I don't like. I'm just going to put all that in there, see if that's going to fix it. Okay. It doesn't like that code at all. So let's. I truly don't know what's going on with all that. Okay. And we can change that in the NC post, just so we don't confuse our staff. Again, not dealing with my speeds and feeds right now, but I do know that because if it's a tool, a 15 thou tool nose radius for a finished tool, I'm going to give it honestly closer to a 3 thou feed per rev. But we'll talk about that more later. Geometry. Okay. Yes. Model front, that's going to be just fine. Radius. Let's get that retract down in and our clearance down in much better. 100 thou, 100 thou. Yes. Distance to cut below. 15 thou, please. If you wanted to go a little bit further, 16 thou, fine. We don't need multiple passes. We've already done all that kind of stuff. All that looks fine. We don't want that angle. That's not very nice to our operator. So we're going to change the same as lead in. We're going to turn that off. We're going to turn our lead in angle to 90 and our lead out to 0. Nice 90-degree angles. Much more better. Okay. Clicking that okay. And see, now when it's coming in, the operator knows where it's coming in and can predict the action. That'd be good. All right, now we're going to turn profile, and we're going to make we're going to help ourselves out a little bit here, because that corner is going to be a little chunky for the finish tool. And this may be made of regret. We're going to find out. So let's see here. Okay, tool 2. Again, ignoring the stuff. We're going to shorten this up to just there. And we're going to go model, select, open chain, and we're just doing that one. That's all we're going to do on this at the start. Radii. Pull that in. Pull that one in, not going all the way in just for safety. Passes. I actually want to try. No, we're not going to do it in passes. We're going to do it in stock to leave. Yes, let's do that. Let's leave it a 10 thou here and a 10 thou there. And let's see if we think that's going to survive. Nope, it didn't like it. How come? All right. Let's try. Edit. Let's try turning off the model and see what happens. All right, it's happier there. Fine. Now I don't prefer that angle on it. Let's change that lead in angle to a 90. Well, that's a weird angle too. Well, it's because it's on that curve, right? And so it's kind of hard to gauge. Let's put that back to the 45, 65. I don't feel like doing the trig. I should. Well, anyhow. It's going to hog off that extra bit. Is that going to be too much? Let's go get a peek. Oh, wrong one. My concern is whether or not it's going to bend our spindle. Slow that one down. Well, it might survive, might not. We're just not going to know until we run it. So once again, and that's okay. As long as you have a decent communication-based relationship with your setup person, which might actually be you, it's okay to have some things that you're unsure of and say, hey, I'm not sure about this. Can I see you run it? And usually they say, yeah, okay, come on down. Okay, so we did work there. So why repeat it? So I'm going to do a right click and duplicate. Do a left click, then a right click, edit. Going down to geometry, we're turning on model. We're going to select open, grabbing all of this stuff in here. I have a suspicion I'm going to have to change something. We're going to find out. Okay, and back tangential extension, we're going to do that 0.155 again. And we're going to bounce this back out to our stock. What am I missing? Stock to leave. We're turning that off. There we go. Let's see what we do. Oh, I know what I missed. Here we are. Aha. Not quite what we want, but it's close. We're going to go back in, edit, and we're going to make certain to turn off grooving. Don't allow grooving. Nice. Okay, then we're going to go to setup 1, and we're going to simulate. And here it goes. I didn't like that travel up, that face at all, did it? Yeah, on this face and that face. It will do fine. There's a little grumpy there. It might end up a little bit chattery. If it is, we would set up some separate tool paths so that it travels down this one and down this one, and then come back and finish everything up. But I've done this before, and it turned out perfectly fine, so I think it's just being overly whiny. Okay. But by traveling that outline, everything's matching up perfectly. Okay. Now, that blue thing hiding in there is its theoretical turned face. And it's behaving today. But there are days when it does not, where in here it just cuts all that off or sweeps down in something crazy. Keep that in mind. I like having that outline so that I can protect myself from a badly extrapolated part. Okay, next we're gonna do some grooving. Tool. And we're gonna go to turning tools. And we're going to turning grooving. And I don't know much difference between them. I know this one down here has a round button, and that's not what we have in the shop. I'm going to go to this one here. Bonk. I'm going to select it. I'm going to go back in. And I need to actually measure our inserts, but it is my belief that the part off inserts that we have are, let's see, where is that? Not there, not there, not there, right here. I believe our groove width is actually 1/8 of an inch. I need to confirm that, and you guys would have to as well for yours. We'll talk about that later. Okay, 0.125, and I'll let you guys know if I discover otherwise. Yep, corner radius. I think that's just fine there. 64th. OD grooving, 0.125 width. Put that over in comment. The thing you put here is what will end up in the code for the operator at the beginning of the toolpath. That's handy. Okay. Again, feed and speed, different day. All right, I'm going to drag this front back to here. And I don't want a razor blade, so I'm going to bump this back to here. Okay. And I'm just going to leave it as it is, I think, at this point. Now my inner, I don't want to come all the way down or it's going to fall off. So I'm going to bump that out to being like, that's a 0.1 radius. So that's a 200 thou diametral. I think that will be strong enough and we'll have saved us a lot of time in Op 2. Because again, Op 2 needs to be gentle. Passes. Okay, we're going to leave all that alone. Maximum grooving step over 40,000, nowhere near enough. We've got 1/8 of an inch total, but we do want some overlap. I'm thinking we'll still have decent amount of speed if we go with a 0.075. Might do 100 thou, but I think 75 thou will do just fine. I tend to like pecking to break the chip. Yeah, okay. Let's leave that alone, see what it does. Let's give it a stock to leave. And we want to make sure that that's 10 thou on radial and axial. We'll come back to this if we need to. Bum, 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 bum. Okay. Let's see what that actually does. I didn't like that second step over. It was pretty chunky. See, I've got two of those there. I don't know that I prefer that. Let's see if we can minimize that. Let's see here. Roughing passes. There's some grooving step over. Tracking retract. Let's turn that off. Aha, there's just one. See what that looks like. Go. Zoink, 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 zoink. Yeah. I like that better. You may not. You can make different choices, and that's okay. We'll find out. And then we're going to go with a part off using the same tool. However, let's see. That's looking fine there. This is a bit much out here. Let's see if we can reduce some of that. Retract and clearance are on the same spot. So let's change our retract to being outer radius plus 0.1. No, not 1 point. 0.1. There we go. Slight difference. Okie dokie. That looks much better. But we're going to use a stock to leave. And I want axially to leave 30 thou. And it didn't update in the drawing. Keep that in mind. Okay. That looks pretty good. Now, you're going to want to use a parts catch, and we're going to want to add that to the code manually, or simply not come down all the way to 0 for the part off so the operator can snap it off manually. But with this thickness here, I don't know. Depends on if we're on the TL1 or the SD10. All right. Feeling okay there. And that first one is looking like it's going to be approximately a minute. That's pretty cool. Zoink. Now, partially I was leaving the speeds and feeds off because I had not decided what material I wanted to cut today. And two, I wanted to leave you guys time enough to work. And ask questions. Yeah. It says we're crashing, but I don't believe it. I think it'll do fine. So I didn't like the size of those steps there. Just now watching that. You might want to change that. But may as well run it, see if it works, right? Before you make, why make changes to something that doesn't need it? And we don't know until we have more data. Okay, let's save that real quick. And this one, hang on. We're in 215. Okay. I'll be in 215 spring. There we go. And we're calling this Lathe 2. Lathe 2. Terminate. Okay, I'm going to stop my recording. I wonder if this is, by stopping that recording, is it going to splice all that together? Or is it going to be separate recordings? I don't know. All right, so hang in there. I'm going to dash off and check on the guys in the shop. I'll be right back. Ponder questions. Okay, I have returned. Now let's turn this on, recording again, and see what happens. Okay, so we have gone through design and we have gone through op 1. Are there any questions I can address at this point? Well, if they pop up, feel free to let me know. Okay, so let's talk op 2. So I'm going to come up here to setup again. And we're going to click on that and see they've gotten a setup 2 there. Some small things we're going to change though. We're going to go into stock and we're going to go, the default was from preceding setup. Only this time, we're going to add in continue rest machining. Actually, let's try something else. I haven't done this one before. Let's try a fixed sized cylinder. And model position, well, we're going to come back to that. Okay, well, we see that our Z is facing the wrong direction. We want it to be like here. And I'm going to switch those bodies there. And so we're going to flip the Z axis. Duke, there it is. And we don't want it on the stock front. We want it on the model front. Okay. Now, at this point, we're going to go back to stock. And model position, it's going to be from front. And we're going to add in 30 thou. And let's see if I can make this work the way I want it to. Doesn't always work out the way I want. All right, setting our safety up a little bit closer. And let's see here. I think everything's looking okay there. All right. And we're going to name this one 52403. Third program of my day. Ta-da. All right, it's not doing what I was hoping it would do. It's showing the model. It's okay. We're going to keep going and see how it goes. All right, face. I already did it once. Why do it again? So I'm going to duplicate, grab that second one, drag it down to setup 2, open setup 2 again, go into face, make some changes. I'm going to go edit. There it is. Just right. And I hardly had to do a thing. Isn't that cool? Okay. And now I'm going to grab profile roughing. And I'm going to duplicate. And I'm going to grab profile roughing. And I'm going to drag it down here. We can see that it's going to go where that blue line is. There it is. And I'm going to edit. And I need to make some changes on this one because we had it just itty bitty there, right? Well, now we're going to bump that. Oh, no, we wanted it all the way in. There we go. That's what I wanted. I remember now. Get that clearance in a little bit. There we go. Okay. Passes. Oh, no, I did want that in. I remember now. Boy, I've got the dumbs today, guys. Don't mind me. Let's try that. See if that's going to work out. And with that being the case, let's move this one up to here. so we don't waste time. Oh, hey, look at that. It's kept our previous chain. But let's change that to being okay, those two. Okie dokie. Everything else should be okay. See how it does. All right, we've got a little extra that we don't need on our toolpath. We could rein that in using our radii and our geometry. But all in all, I'm just going to leave it alone. It's not going to hurt anything really. It's just going to be slower. Now, it thinks it has material here, which could be a problem. But I'm going to ignore that for now and hope. So I'm going to duplicate that profile here. And I'm going to drag that one down to here. Gonna edit. Let's change our geometry so that, well, for one, our fixture is going to be holding this, right? So it's going to be right along that line. And we've already cut this line right across here anyway. So we don't need to do that. So let's drag that back to, well, let's start here. And then we'll kill that tangential extension. And let's take that back another, 30 thou and see what that does. Probably more than we need. We'll just see what happens. Okay, our contour, though, is going to be an open contour, grabbing all to here. We're not going to go past here because you've already cut that. So honestly, in our design, we should probably have a little bit of a fillet on this corner so we don't get a burr, because we have a very solid chance of having a burr right here because of that. It's all right. We'll leave it alone for now. I'll just mark you down later for it. Akid. Let's check our radiuses. Everything's good there. No. Let's turn off sharp corners and maybe it'll get rid of some of those burrs. Let's find out. See what it does. Okay. I still don't like this one here. I would probably, if it were my time, instead of wasting you guys' time, I'd probably play with it until I got it to coming in straight. Just for the sake of the operator. But all in all, looking pretty good. Let's run the whole thing. I'm going to turn off my sketches and bodies. And here we go. Zoink. Burp. 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 Facing. Now we're taking off that corner. Who knows? Maybe it'll be good. Maybe it won't. We'll find out. And those aren't really crashes. Oh, that's really aggressive. Probably want to change that. There. Okay, that material is there, not there, so it didn't crash for real. Okay. Probably should have faced with that finish tool there in between. Yeah. But all in all, we're looking at it. That's a nice profit. Okay. So let's turn those bodies back on. That is the large part of our lesson for today. If I change that over to a visual style of shaded, and we made that. Hopefully so. I think it's been pretty decent. Who knows? So I want you guys to do something akin to that. The features you need is it's got to have a point to spin on. I recommend a more than 1/8 of an inch between the tip and the flywheel. It can be shorter. It spins better when it's shorter, but it's harder to get started when it's shorter. The diameter for the nose here can be anything you like. Rounder ones are easier to start, but don't spin as long. Or that is to say, larger diameter ones. Do whatever you want for the flywheel. I recommend either on this side or on this side of the flywheel of having something for an op2 collet to grab onto. And then you want some fashion of spindle. Make your own choices there. And that is your second project. You don't have to do it, but I think it would be really cool if you did. In terms of materials, I have 6061. I have brass, and it's free turning brass, I believe. So it's got a little bit of lead in it. Beware. They say just don't let a kid suck on it. Otherwise, you're fine. It's like it has less lead than keys do. How's that? Yeah. We have mild steel. We have, I think it's 304 stainless. I'd have to check with Ben. And I think I have some 17.4 tool steel. My recommendation is mild steel, brass, or aluminum. Otherwise, go ahead. Do what you want to do. Brass does spin pretty good. It's a little harder to get started, but on a good spin, it spins longer. And I think it's pretty. And we can always go back and adjust your feeds and speeds Monday. This is what I want you guys working on. If you want to, you also have your first project, the block and peg, to do. Yes, this is much more complicated than the block and peg, but lathes are harder to crash than the mill, in my opinion. So I'm going to stop the share at this point so that it will stop Kenneth's recording, and I'm going to stop my own as well. I'm going to wait for 10 minutes. And then open the Zoom meeting up again so that I'm here if anybody has questions for me via Zoom. The rest of class is lab time. All right. So that is to say you can stay here and work on stuff, or you can go home. I don't care. It's up to you. We are all adults. All right, stopping the share now.